Now let us discuss about the third law is Gay-Lussac law, where it talks about the pressure versus temperature. So here for the Gay-Lussac law, we have to keep that volume of the gas, should be constant, means K. It should be constant. So as per the Gay-Lussac law, the pressure-temperature relationship, the volume of the gas should be constant. Then we have to relate the pressure versus pressure is directly proportional to temperature. This is the Gay-Lussac law observation. So how the pressure is related with the temperature for the fixed mass of the gas and for the fixed volume of the gas, so we have to study. If you want to understand this pressure versus the temperature, so we have to study one example with the inflated tires of automobiles. If you take the inflated tires of automobiles, the inflated tire having that fixed volume of the air inside. So the volume is constant in the fixed volume of this tire, and in this the gas is filled with some pressure. The gas is filled in this tire with some pressure. So since the pressure is inside in the hot summer, so what happens means the pressure increases. When the pressure increases, so because of that pressure increases, temperature increases, and with this the tire will burst if the air pressure is not adjusted. If the air pressure is not adjusted, the tire will burst. But during winter season, what happens? On the cold morning, the tire deflating will happen, or the air pressure decreases. The automobile tire will become flat. It will become flat during the winter season. That means pressure decreases, then temperature decreases. So from this example, what we can understand means pressure is directly proportional to temperature. Pressure is directly proportional to temperature. Then if you take out the proportionality constant, P is equal to K into T. This is the equation we can get, or P upon T is equal to K3 constant. So this is the equation we can get. This is the equation that talks about Gay-Lussac law. So relating the pressure and temperature. If you observe in a mathematical relationship, the mathematical relationship between the pressure and temperature was given by Joseph Gay-Lussac, is known as Gay-Lussac law. It states that at the constant value, what does it says means, at the constant value, the pressure of fixed amount of gas varies directly with the temperature. So mathematically. So P in directly proportional to temperature, P upon T equal to constant, and P1. So at P1 pressure, the temperature is T1. At P2 pressure, temperature is T2. At P3 pressure, temperature is T3, which is equal to constant. This relationship can be derived from Boyle's law and Charles' law also. The pressure versus temperature graph at constant molar volume shown in this diagram. So each line of this graph is called isochore. Isochore at the constant value we can get straight lines. So we will find that this is the same number which we came across while discussing the definition of mole also. 1 mole of the gas occupy. So 1 mole of any gas occupy the volume 22.7 liters. 1 mole of any gas. Let us say 44 grams of the carbon dioxide. So occupy the volume 22.7 liters under the STP conditions. So look at this graph. In this graph, so pressure is taken on this y-axis and temperature is taken on this x-axis. You can see. So the pressure is taken y-axis and on the x-axis temperature is taken 0, 100, 200, 300 and 400, right? So and when pressure increases, the temperature also increases for the at the fixed value V1. So this is a straight line. V2, V3, V4, then automatically V4 is greater than V3, V2 and V1. So this is a graph we can get, and these straight lines are called isochores. Isochores are the straight lines. So isochore are the lines we can get if we plot so pressure versus temperature as per the gaylussac law. So next to gases law, very important. Gases law is about Avogadro's law, we say, or this is otherwise called Avogadro's hypothesis, which talks about volume versus amount, means N, number of moles, we say, or number of molecules. The relationship between Avogadro's law talks about the relationship between volume of the gas and its number of molecules. It states that equal volumes of all gases under the same conditions of temperature and pressure containing equal number of molecules. So equal volumes of all the gases containing same means under same conditions of temperature and pressure contain equal number of molecules, we say. That means the volume is directly proportional to N. This means that as long as the temperature and pressure is remain constant, the volume depends upon number of molecules of the gas. In other words, the amount of gas, mathematically we can write volume is directly proportional to N number. Moles of the gas, we say. That means V directly proportional to N. So if you take out the proportionality constant, then V is equal to K4 into N, where V upon N equal to K. So at V1 volume, the number of molecules will be N1, and at V2 volume, number of molecules will be N2. So V1 is the initial volume of the gas, N1 is the initial quantity, means number of moles, V2 is the final volume, and N2 will be the final number of molecules. Finally, what we can understand means at constant temperature and pressure, we will find that the same number of molecules which we came across while discussing the definition of mole. So, and from this we can get mole. The number of molecules are present in 1 mole is the Avogadro number. This Avogadro number of the molecules will occupy the volume, what is called molar volume, we say. Molar volume. So the molar volume is the quantity of the substance 1 mole. 1 mole. So 1 mole occupy the volume is said to be molar volume we say. So Avogadro number, this Avogadro number is equal to 1 mole. 1 mole containing Avogadro number of molecules. Avogadro number of molecules occupy the volume is said to be molar volume we say. 1 mole of each gas at standard temperature and pressure STP condition will have the same volume. The standard temperature and pressure is 273.15 Kelvin, which is equal to 0 degree Celsius temperature at 1 bar equal to, so how much? 10 to the power of 5 pascals. So these values approximate freezing temperature of water, atmosphere pressure at sea level, and STP molar volume of ideal gas or combination of ideal gases is how much means 22.7 liters per mole. Let's have complete discussion. For example, argon is a gas, argon gas is given. Its molar volume is 22.4 liters or 22.7 liters STP take. The mass is of the argon is 40 grams. This is that gram molecular mass 40 grams. Occupy the volume 22.7 liters. The quantity that forms 1 mole. Pressure it can create 1 atm. Temperature at 273 Kelvin. So this is the molar volume of the 40 grams of this is a 40 grams of argon. Similarly, O2 oxygen if you take, the molar volume of oxygen is 22.7 liters and its molar mass is 32 grams. 32 grams occupy the volume is 22.7 liters, which is equal to 1 mole at 1 atm 273 Kelvin temperature. Similarly, nitrogen gas also occupy the molar volume how much? 22.7 liters. 22.7 liters it occupy. Its molar mass is 28 grams, which is equal to 1 mole at standard temperature, pressure, 1 atm pressure, 273 Kelvin. So that means here the 1 mole means all these gases will have the same volume. So same volume and containing same number of molecules. Same number of molecules. So this is